Hi there, and welcome to part 8 of the Learn to Program series. This episode we're going to look at functions. Functions are really useful things. Functions are well-defined mathematical objects which map an input to an output, or map a domain to a codomain. But we don't need the mathematical nomenclature in order to succeed at programming functions. Let me give you an example of a function because I think it will become very clear once you see what it looks like. So here is a function called d, which takes an integer argument called x and it returns, got to put returns in. It returns x times 2. So what this function does, the d stands for double, it just doubles whatever argument you put in there. X is the argument. So if we put in 5 it's going to return 10, if we put in 10 it's going to return 20, and so on. So that's actually what a function does. And the way functions are defined in C is as follows. We write the return type, so we're returning an int, then we write the function name, the name in this case is d, we then write an open bracket, and there's a closed bracket here, and within the brackets are a list of arguments. Each argument is written with its type and then a name for that argument. The name given to an argument can be used within the body of the function, so within these two braces. So after your argument list you have an open brace, a number of statements which must terminate in a return to return the thing you said you were going to return, but you can actually return anywhere in the body. But you always have to have a return at the end, otherwise it will complain, because it can't execute. It doesn't necessarily know all the paths that the code can take, but we'll go into that later. And then you've got your closed brace. So this x here refers to the value that we've passed in. So if we were to write print f and d for a decimal, and then if we use as an argument d 5, this will print out the number 10 because the argument to the decimal modifier in the printf string is a call to the function d with the value 5. The value 5 goes into the function, and now the name x is bound, the variable x is bound to the value 5, so x has the value 5. This arithmetic is then performed, x times 2, to give the value 10, which is then returned, and that's an integer. So we get an integer value 10 here, which is then printed out. So let's take a look at that. I'm just going to create a makefile with a default in there called hello function. And in here we're going to have a main. We need to include standard input output for our printf statements, and we're going to declare our function here. So we start with the type that the function returns, which is an int. We called it d. It's got one argument, which is an int, which we're going to call x. So we can call this anything we want. We don't have to call it d. We can call it squiggy bobbly 5000 if we want. We're going to call it d, but we can call it whatever we want. Now in the body of the function we're going to define what it means to be this function, and we're going to return x times 2. Pretty simple. And then in the main we're going to call this with value 5 Let's call it with the value 10 and the value 20. So let's take a look. That's compiled, and now to run it, and it prints out 10, 20 and 40, which are of course the doubling of our arguments 5, 10 and 20. So you can see that it's actually very simple to define a function and then call the function. We can also, I'll just quickly say now, we can call the function and assign a value to a variable like that. And then if I print out the variable p, we're going to see the value 50 on our last line. There we go. So the return value from your function can be assigned to any variable. So let's just take a look at some of that stuff to understand in a bit more detail what's going on. If I just write the function up there again, so it's a function called d that takes a single variable called x, and it has a single purpose, which is to return x times 2. And then we have our main function. And all our main function does is prints out d called with the value 5. And then because it's a main function, it itself returns the value 0. So here our function is declared, and you saw from the example that by doing this we're calling the function with the value 5. So when we call a function that we've defined, we use the name of the function that we gave it. So the name can't be the same as an existing function. So we couldn't have called it printf because we would then have a clash. If we didn't include standard.io.h, then we could call it printf, although the compiler might have something to say about it because printf is kind of a special name, and anything in the C standard library is kind of special. But we can call it whatever we want as long as we don't clash with any other name that exists in any of the libraries that we've included. So we give it a name, and to call it, we provide the name, we have an open bracket, and then we have the arguments that we want to pass into the function, separated by commas, and then a close bracket. Now, when the value 5 comes in, it is bound to the variable x, and x takes the value 5. X, within the scope of this code block, x is actually just like any other variable, any other integer variable. You can change the value of x within the scope of the block because it's just a variable. It's as if you had declared here int x equals 5. That's essentially what's happening here. And in C, arguments are always end up in a function as copies of whatever you pass in. There's something called pointers in C which allow you to manipulate objects that are outside of your function, but this is essentially still passing in a value. The pointer has a value, so you're always passing in value, and that's called pass by value, and that's what C does. So if we had a variable here called x or whatever, and then we pass that into the function and modify x, it won't change the value. It won't change the variable here because it only takes the value that we pass into the function. We'll do some examples of that in a bit to make that clear. Now, it's important to look at where the functions are actually defined in our program. You saw that we defined the function d and the main function in the same file before. So if this is our file, imagine the whole whiteboard is our file, then we've declared d here. Because we're using printf, okay, let's be precise, we also have got an include standard io.h here, and this is our complete file. We've declared D here, and because we've declared it here, it's the same as if we'd declared a variable there. We can now use D from that point onwards. The compiler knows about it. So when we call it here, that means the compiler knows that that function exists and it knows what to do. It knows how to call that function because it's already seen it. So what would happen if we hadn't seen it? So let's try swapping around D and putting D below the main function and see what happens when we try and compile it. Let's take a quick look at that. So let us declare our function down here instead. And we'll call it with the value 5 up here. So then if we try and compile it, we get this error. Declaration, line 3, character 16, warning, implicit declaration of function D is invalid in C99. And what that means is we cannot call the function D because we've not declared it. And we're not allowed to implicitly declare it. You can do that before C99. So we have to explicitly declare it. So as you can see, it doesn't compile. And the way to solve that is to do what's called declaring the function first. So we can actually put the function wherever we want, but we have to declare it before we use it. And we can do that then. We can explicitly declare something by putting it before where we use it. So we just write what's called the function prototype here, which is essentially just a function without its body. Now it's declared, and the compiler can use it, and then it resolves it during the linking step, and everything's fine. So let's check that out. Compile it. There we go. No complaints upon compilation, and we get the value 10, which is what we expect. Now the reason it's really important that you can do this, because when we do, for example, I'm not going to go into a lot of detail, but just to consider when we call printf, we haven't defined what printf is. But printf is declared in this file here, standard.io.h, which is included, which means that the compiler doesn't complain because we've already declared it in standard.io.h. I'll have a look at this. I'll show you now where it is. So let's try and find where standard.io.h is. I can use the command locate to look for it. And there's actually quite a few cases, but the one which it will be is, on my system, is actually user include standard.io.h. So if I then have a look at that, we should be able to find the declaration of printf. And, yep, there it is. So that is the declaration of printf. There's no, as you can see, it just ends in a semicolon. There's no function body there, just the declaration. So you can see that it's actually in that file, declared, but not defined. It's already been defined somewhere else and compiled into what's called a library. And then at the linking stage, that name printf is then resolved to a symbol and then linked against the appropriate library where the actual definition of the function is. So that allows you to then include functions that are in other libraries, external libraries that have already been compiled, by including their declarations in headers. Don't worry if that was a bit too much. I just wanted to mention that because we're going to look at that in the future. For now, what we're going to do is we're going to keep all of our function definitions and declarations in the same file. And most of the time, we're just going to declare them in such an order that whenever we use them, they've already been declared and defined. So we won't have that problem. We're going to have a single file and all our functions in there. So we're just going to do that for now, and probably for the next couple of episodes, because it's easy. And often that's the easiest thing to do, and it makes a lot of sense. So functions are very simple. And they allow you to save a lot of time. If you were doubling, in the case of doubling like this, it's not really obvious why that would save any time. So let's give an example where it would obviously save time. Okay, so imagine for some strange reason you want to print out the numbers between a start point and an end point, and you're doing this all the time. You could write a function like this. Void. Void is a special type that we haven't seen before. So this is the return type of our function. And void means that it essentially has no return type. It doesn't return anything. But we have to specify a return type, so we specify void. Now, let's call our function p. Normally we'd use more descriptive names for our functions, but because I don't have a huge amount of space on the board, I'm going to use short names. And it's going to take 2 arguments. First one is an integer called s, and we put comma. So arguments in a function declaration are separated by a comma. And our second argument is called e. So we've got int, and there's a space between int and s, obviously. S and e, so that's a start and end. Now you've seen loops, so we'll do this using a loop. While s is less than or equal to e. And we're going to do the following. We're going to print s out. And then we're going to increment s. And that's our function. So we take the start and end integers. To begin with, say it's 5 and 10. S is 5, so less than 10. So we print out 5. Then we increment s, so s becomes 6. We print out 6. Print out 7, print out 8, print out 9. We print out 10, because s is equal to our endpoint 10. Then s becomes 11 and we terminate. So we've printed out the digits between and starting at s and ending at e. You can imagine if we had to do this many times in our code, we wouldn't want to keep putting out this loop again and again in the code. We could just write p, 5, 10, whatever the values were, and maybe these values change over and over again. And our code would be much shorter, because this function would be put somewhere and we just have these p statements everywhere. So that's an example of a function where it saves you a lot of space. Of course, when you're doing very complicated things, involving many functions, involving structures and arrays and so on, then functions are a necessity, because you'll find yourself repeating, you'll find that you'll be repeating yourself over and over again. And that is really what happens in programming. It's the structure and the way that I think all of reality seems to work, is that things are repeated, and they can be broken down into repeatable steps. Think of how nature works. Everything is built up from fundamental blocks that are repeated. That's how physics works as well.
Well, before we get too philosophical, let's actually have a look at that. So let's declare the function. It returns nothing, so it returns void. And we called it s, didn't we? And it took we called it t, and it took 2 parameters, s for start and e for end. But let's give those different names actually. So what this is let's call it range underscore print. And start indexed, end. Actually, we'll just have start I and end I, so that I don't have to go past the end of the line. So that's declaring our function, and then within the body we have this. So while start index is less than or equal to end index, print out the index. Oh, and that was it. Oh, and increment the index, of course, otherwise we'd never stop. And then let's do a range print here then. So we can call a range print, and let's say between 5 and 10. Let's compile that and run it, and it prints the numbers 5 to 10. By the way, strictly, something like printing out is called a side effect of a function. Whereas the value that a function returns, if it returns a value, is, you know, the real application of the function. But that doesn't really matter. And what we can do then, of course, is we can do range print for anything we want. We could do range print 1 to 3, range print 5 to 8, followed by range print, I don't know, 80 to 90. And compile that and run that. And we've got 1, 2, 3 from the first call, 5, 6, 7, 8 for the second call, and then 80 to 90. And sometimes it's quite useful just to see what happens in the function. So we could, for example, print off entering range print, and then we could print exiting range print, just to really see what's going on. Run that, and we can see when we enter and exit. And if we call that multiple times, you can then see we enter and exit the function each time the function is called. So that's it. That's how we define a function and then execute the function.
So we'll just say a couple of things more about functions before we stop. Within a function body, you can call another function. So we've been calling printf within our functions, and we can do that to any depth we want. So our function A might call function B, which in turn calls function C, and so on. The interesting thing about functions is they can also call themselves, and this is called recursion. Now I'll give an example of this, because recursive functions are incredibly powerful things, though they do waste a lot of stack space for big call depths, but don't worry about that. So we're going to define a function, and it doesn't return anything, it's just a void function. I'm going to call it countdown. And what this does, it just counts down from whatever number we provide. So it takes one argument called x, and there's our open brace. I'll put the closed brace here. Now the first thing it's going to do is check whether x is 0, or actually less than or equal to 0, let's say. So if x is less than, in other words, is less than or equal to 0, then we're just going to return. We don't return anything because it's void, so that just means we stop right there. Otherwise, what we will do is we're going to print out the current value of x in our kind of the normal way that we're familiar with now. And then we're going to call countdown again. But we're going to call countdown with x minus 1. So I wonder if you can see how this works. So say we call it with the number 10. Well, 10 is not less than or equal to 0, so we print out 10. And then we call this function again, but with the value 9, 10 minus 1. So then we print out 9. We keep doing this until we've printed out 1, then we call countdown with the value 0, and then we just stop. And because there's nothing below this statement, all the other functions will also stop. Because when we call a function, execution does not continue on to the next line until that function returns. Let's take a look at that.
We're going to need our standard.io, and let's define our function. So it returns nothing, it's called countdown, and takes a single integer argument x. if x is less than or equal to 0, then we do nothing. We just return. By the way, we don't have to use braces in an if statement or a while statement. We can just put a single statement on the next line, but I prefer to use braces. If x is not less than or equal to 0, then we're going to print out the current value of x and then call countdown again with x minus 1. Now, if we call countdown from our main with the value 10, let's see what will happen. As you can see, it prints out from 10 down to 1. And what it's done there is called itself 9 times for the values 9 to 1. But what's interesting is to observe then what the flow of execution looks like. So if I say entering countdown and we have exiting countdown, and then we run this, but we'll run it for a slightly less number so that we can see what's going on. So here we go, this is quite interesting. So we enter countdown for the first time, but we don't exit countdown because we've called countdown again. So now we're entering countdown again for 4. And again we don't exit countdown because x is not less than or equal to 0. So we enter countdown again for 3, and for 2, and for 1, and so on, until we enter countdown for the final time, at which point x is 0. And then we just return. So we return, which actually kind of pops us back up into the previous call of countdown, which means that we're here. Then we execute the next line. So then we see an exiting countdown. But that's just exiting from the case when we went through the loop and printed out 1. And when we printed out 1, we call countdown. So we've exited that, and we print off exiting countdown again for the time when we went around the loop for 2, and so on. So we see all the exits at the end because we've kind of built up a bunch of enterings every time we called it, and before we had the chance to exit, we called ourselves again, and then that's why we saw the exits at the end. I'd advise you to work through that and think about what's going on there and try and understand that.
That's all I want to say about functions. All of the functions we've looked at use integer arguments, but you can use double arguments or any other type as an argument. And you'll see that in the next examples, in the next episodes. Now that you're familiar with what a function looks like and how to call it, you'll see many different types of function and understand more about them. But that's the basics of functions. And if you want, as an exercise, try and write a function to print out the first x Fibonacci numbers. So what is a Fibonacci number? So Fibonacci numbers are the following sequence. It starts with the pair 0, 1. They're the first 2 Fibonacci numbers, and that's how it's defined. The next Fibonacci number is defined as the sum of the previous 2. So the sum of 0 and 1 is 1, so that's the next Fibonacci number. And then the sum of 1 and 1 is 2, so that's the next Fibonacci number. The sum of 2 and 1 is 3, that's the next Fibonacci number, and so on and so on. And we'll say that this is the first Fibonacci number. This is the second Fibonacci number, this is the third, the fourth, and so on. So the function prototype is going to look like this. It's actually going to be void, it doesn't return anything. And it's going to be called fib, and we pass in an int called x, and that x will correspond to the index, and your job is to define the function fib that prints out the first x Fibonacci numbers. And I'll show you the solution to that in the next episode, but for now that's what I want to say about functions. There's a couple more examples in the Git repository, but hope that was useful, and I'll see you next time.